We'll look at question 3 of your mid-year exam paper 2. In the diagram, ABC is a straight line. Vector AB is represented by the vector P. Vector BD is represented by the vector 2Q. And we are given that the length of AC is 3 times the length of AB. Now if you look at this, since they told us that the length of AC is 3 times the length of AB, but we know that ABC is a straight line. So vector AC is in the same direction as vector AB. And since we know that AC is 3 times the length of AB, then we can also say that vector AC is 3 times of P, vector P in this case. For part A, they want us to express the following vectors as simply as possible in terms of P and Q. Now for vector AD, my starting point here, AD, so I can choose to go by AB plus BD which is simply P plus 2Q. Now do remember your sign to represent a vector. So you need to include a curly sign. Let's go on to part 2. Part 2 wants us to find vector CD. So I can choose to go CA, then AD. You can also choose to go via the route CB, then BD. So CA is actually the negative of AC, and we know that AC is 3P. So CA is negative 3P, and we have found AD in part 1. So my answer for this would be negative 2P plus 2Q. Let's go on to part B. E is a point such that DE equals to AB. So I know that vector DE is equals to vector AB, meaning vector DE is essentially vector P. They want us to describe 2 facts about vector DE and vector AC. Now, if I know that vector DE is the same as vector AB, and they are in the same direction, I can conclude that vector DE and vector AC is also in the same direction as AB. The 2 vectors will be parallel in the same direction. This will be the first fact about the 2 vectors. Now a second fact about the 2 vectors. Okay, since I know that vector DE is equals to vector AB, then vector DE is also related to vector AC by this. And what does this mean when vector AC is 3 times of DE? I will be able to compare the length or the magnitude of these two vectors. So the magnitude of AC is 3 times. You can use magnitude or you can use length of vector DE. This would be my second fact. For part C, they want us to calculate the ratios of some of the figures. So for C part 1, they want us to calculate the area of triangle BCD over the area of triangle ACD. Let's go back to the diagram. Triangle BCD over ACD. So BCD is over here. And triangle ACD is over here. Now these two triangles are not similar, but these two triangles do share a common height. So I'll make use of this to help me find the ratio. So the area of if I were to write this down, area of triangle BCD is half times BC times the height. Area of ACD is half times AC times the height. Then I'm left to compare the ratio between the length of BC and AC, which is 2:3. So my answer for this will be 2:3. Now for the next part, they want to find the ratio of triangle BCD over the area of trapezium ACED. Let's go back to our diagram. So I'm trying to compare triangle BCD with trapezium ACED, which is the whole thing. Now we will start by first writing out the formulas for these two. I do have some relationship because I know that DE is related to AC. So if I write this down, again, I relate the two figures to their common height H. So both have common height H. Area of a trapezium is half times the sum of the parallel sides times the height. So when I write this down, I realize that I have to compare the ratios of the length of BC over the length of AC plus DE. So BC, I can say that it is 2 units over AC is 3 units plus 1 unit of DE. So that's 2 units to 4 units. And simplifying it will give me half. So the ratio of these two areas would be half.